equal to 1, 2, 3. Input x of n is equal to, in an LTI system, input x of n is equal to x of n is equal to 1, 2, 3. Impulse response h of n is equal to minus 1, minus 1. Input x of n is 1, 2, 3. Impulse response h of n is minus 1, minus 1. Determine the response of the LTI system. Determine the response of the LTI system. Determine the response of LTI system using radix 2 DIT FFT. How can you perform this? Given x of n and h of n, now we are supposed to find the response of this system using radix 2 DIT FFT. If it is response, if you are asked to find response, what you are supposed to find? What you are supposed to find? See, if you have understood all the concepts that we have seen so far, then very well you can give the steps for performing this particular, that is for completing, for solving this particular problem. If it is given that you have to find the response, what you are supposed to find?
Linear conjugate.
No. Tell me what component you have to find at the out.
Y
Find it.
of n.
It is y of n. So our aim is we have to find what is y of n. This is what we have to find. Yes, good. And as you know, you have to perform linear convolution. Only if you perform linear convolution, you will be obtaining the response of the given LTI system. The method that you have to use is, what method you have to use to find this y of n? What is given in the problem? It is DIT FFT, and this FFT is a technique which is used to compute n point DFT, which is used to compute n point DFT. So the method that we are supposed to use to solve this problem is IDFT and DFT method. Okay, DFT and IDFT method. Is it clear? Since the method is mentioned as DIT FFT method, we are supposed to solve this using the method of DFT IDFT. So now the method that we have to use is clear to us. It is DFT and IDFT. This is the method that we are supposed to use. Now using this method, how can we obtain the response? What is the first step that we have to do? If I am asked to use DFT IDFT method to find the response, what is the first step that we have to do?
Convolution
Oh,
of x of n and h of n and the product.
come again. The method that we have to use is DFT IDFT method. Using this method, how can we find the response y of n? It's correct. Sashi Kumar, you can come back. Am I audible to you? Very good. Number of samples must be n1 plus n2 minus 1. Okay. So the very first step that you have to do is make the length of both the sequences to be equal to n1 plus n2 minus 1. What is n1 here? N1 is length of x of n, which is nothing but 3. N2 is length of h of n, which is equal to 2. And this y of n should have how many samples now? Output, you can write it, y of n will have n1 plus n2 minus 1 samples. So here it is how many samples? 3 plus 2 minus 1, which is 4 samples. Okay. Next, what you have to do? After this, what you have to do?
X of k and H of k.
You have to find directly x of k and h of k. Is it like that?
Zero padding, ma'am.
Zero padding. So once we determined the number of samples to be present in the outputs sequence, now you know that this DFT can be performed, a circular convolution can be performed only if the length of both the sequences are same. So you go for zero padding and make the length of both the sequence to be equal to 4 now. Only then you will get the result of the linear convolution at the output. So x of n is equal to 1, 2, 3, 0, and h of n will be equal to minus 1, minus 1, 0, 0. So second step is zero padding. This is what you have to do. First step, determine the length of the output samples, length of the output sequence. That is the first step. Output sequence y of n. So we have determined output y of n, the number of samples in the output sequence y of n. Then we have also padded zeros and made the length of x and h to be equal to 4. Now, third step is what? Third step, you can apply this method, right? This method of DFT, IDFT method for solving this. So if I apply IDFT method and DFT method for finding the response, someone told you, right? Just now you told you. What is the next step that you have to do?
X of n into h of n.
No, it should not be x of n into h of n. Why it is x of n into h of n, you are saying?
X of k and H of k.
Yes, you have to find. See, the method that you have, don't get confused. We are not going to perform circular convolution using matrix method. This is DFT, IDFT method you have to use to find the response. So if you are asked to find the response, linear filtering using DFT, IDFT, we have studied a concept. Not filtering of long data sequences, that is separate, overlap, add and save method. This is how to find the response of a linear filter using DFT and IDFT. Haven't we seen this? So as you said, the next step is finding. You have to find x of k. After this, find h of k. Okay. After finding these two steps, then you are supposed to find y of k, which is, do you remember this? X of k into h of k. Now after the step, after finding the product, you have to find IDFT of y of k. You will get y of n. So these are the steps now you have to follow, right? How will you find x of k? What you have to do if I want to find x of k? X of n is given in the problem. If I want to find x of k, what I am supposed to do? What is x of k actually?
DFT.
DFT of x of n. Since there are 4 samples here, since the length of x of n is 4, I have to find 4 point DFT of x of n. Here again I have to find 4 point DFT of h of n. Multiply these two. Then you find IDFT. Now all these DFTs and IDFTs, we are supposed to use, for finding all these DFT and IDFT, we have to use the method called DITFFT method. Is it clear? Directly we should not apply the formula for DFT to find what is x of k, h of k and IDFT formula. Instead, For finding this 4-point DFT of x of n, you go for DIT FFT method, which means since this is 4-point, how many stages of computations you require to compute x of k if I use DIT FFT method? How many stages? With the help of butterfly structure, we are going to solve this. We are going to find x of k, we are going to find h of k, then we are going to do multiplication between these two and find IDFT of y of k using the same DIT FFT method. How many stages or stages of computations are involved in each and every um, step, that is finding x of k, finding h of k, and finding IDFT, all these three?
You need 2 stages, sir.
2 stages, because here n is equal to 4, which is 2 power 2. This power represents the number of stages, which means that it requires 2 stage. First stage is 2-point DFT and second stage is 4-point DFT. Will you solve this now? Can you solve this? The very first step is to find x of k. Now to find x of k, the given x of n is 1, 2, 3, 0. Okay. And you know that this is 0, 1, 2, and 3. Now what I'm supposed to find? What I'm supposed to find? 4-point DFT. That too in the first stage, it is 2-point DFT. So draw a butterfly structure. Draw 4 lines. Okay. Then in the first stage, we have to decimate the given sequence into 2-point samples. Right? 2-point samples. So draw the butterfly structure for 2-point DFT. You're doing or not? Yes. Next, what am I supposed to write in the first stage? Since there are only it is 2-point DFT, the phase factor involved is W20. Its value is 1. So we need not, it is not necessary to mention the W20 as 1 here. Okay. Directly you can write the samples. In what order you have to write the samples? Samples has to be written in bit reversed order. So can you name the order here? It should be 0, 2, 1 and 3. Is it correct? So it is 1, 3, 2, 0. Find the output of 2-point DFT. After finding the output of 2-point DFT, then you combine the two outputs of 2-point DFTs and find what is 4-point DFT. Find 4-point DFT. Again, in 4-point DFT, you will have two phase factors involved. The values of the phase factors are 1 and minus j. And within the butterfly structure, we are supposed to write what is minus 1. Can you say the output for 2-point DFT and 4-point DFT? Yes?
1 plus 3.
It is 1 plus 3. Say the answer. Say the answer.
4
4
minus 2,
minus 2.
Very good. 4 minus 2. For the
2, 2.
second, 2, 2. Very good. Proceed with the 4-point DFT calculation. Four-point DFT calculation. As you said, it will be, this is 4 and this is minus 2, 2, 2. At this point, what you will get? It is 4 plus 2. 4 plus 2, which is 6. To this point, what you will get? This is minus 2 coming straight away. The other signal that is coming is 2 into minus j, minus 2j. Is this correct? To this third node, 4 is coming here, plus, sorry, it is minus. It should be minus 2, which is 2. Now to this node, it is minus 2, 2 into minus j into minus 1. So plus 2j. You are getting this answer? You are getting this? Completed? Yes. So now we have completed the first step and we have determined what is x of k. Take and write the answer. It is 6 minus 2 minus 2j, 2 minus 2 plus 2j. This is over. Go for the second step. Second is to find h of k. And h of n is given as minus 1, 0, 0. Again, use the same step. This is 6 of 0, 1, 2, 1, 3. Draw the butterfly structure and try to compute it. Two-point DFT is the first stage. Okay. Phase factor involved is 1. Within the butterfly structure, it should be minus 1. And the input is 0 and 2. So it is minus 1, 0, 1 and 3. Minus 1, 0. Find the first stage of computation. Then you go with the second stage. Four-point DFT computation. And here the phase factors involved are 1 and minus j. Completed? What is the output of two-point DFT?
Minus 1.
Minus
Minus 1.
minus 1. Again minus 1, minus 1.
Minus 1 minus.
Very good. Output of 4-point DFT is what? This is minus 1.
Minus 1 minus 2.
Minus 2. Very good. The point la?
Minus 1 plus j.
Minus 1. No. Correct solunga. Second sample. It is minus 1. And this is again minus 1. Is it not? Am I wrong? Second sample. Is it not minus 2 again? Is it wrong? Just check. Third sample is minus 1. Sorry.
Minus 1 plus j, ma'am. Second sample.
Very good. Minus 1 plus j. Third sample is minus 1 plus 1. Fourth sample is minus 1 plus minus j. Now this is h of k. H of k is 2 minus 1 plus j, 0 minus 1 minus j. As I told you, you will get complex conjugates. See here, you are getting complex conjugate value. Someone asked you, that day asked about the real value. If there is no j term, you will get the same real value. Real term is not getting affected. Only the j term, you are changing the sign. You are getting the conjugate. So now we have completed the second step also. Third step is, step 3 is to find y of k, which is x of k into h of k. Tell me what is y of k? Perform multiplication of x of k and h of k and tell me what is y of k. Y of k is what? 12, comma. Yes, I'm waiting for your answer.
Minus 12.
Minus 2, ma'am, that one.
Yes, yes, minus 12. Good, correct. Thank you. Minus 12, comma. Second sample is what? If you multiply this and this,
Four.
only 4,
Yes, ma'am. 4.
4. Next, you're still doing
0, ma'am.
0, minus 4 you're getting.
3, ma'am.
3, yeah. Just check.
Sorry, ma'am.
It should be 4 again. Check, you're getting 4.
4.
Okay, it's correct.
2, ma'am.
4 pa, check panunga. Minus 2
Yes,
plus
ma'am.
2.
4 only, ma'am.
4 only. Okay, okay. Okay. Go to the next step now. Next step is step number 4, which is to find IDFT of y of k. And to find IDFT, you have to take conjugate of, you have to take conjugate of x of k. Is it not? So it is y conjugate of k you have to find. And the second step is DFT of y conjugate of k. Third step, again you have to take conjugate of this resultant output. And in the fourth step, you have to divide it by n. This is what you have to do. Because you have to apply the method of DIT FFT method, right? Now from our result, we got y of k as, it is 12 comma, what it is? Minus 12 comma 4 comma 0 comma 4. Minus 12 comma 4 0 4. As per the step, what will be y conjugate of k? Y conjugate of k will be, since there are no complex terms involved in it, j terms involved in it, it will be minus 2, 4, 0 and 4. The same. The very next step, we are supposed to find 4-point DFT of this y conjugate of k using DIT FFT method. Proceed with that. Is it clear? Any doubt you have? You find DFT of this, the same DFT procedure. So again 2-point and 4-point. What will be the sample input values? It is 0, 2, 1, 3. So 0 is minus 12, 2 is 0, you're able to hear me?
Ma'am, we have to take conjugate, no, ma'am? Y of
Yes,
k.
you have to get conjugate. See, as I told you, Sashikuma, that day also you asked the same doubt, right? If I have real
Okay,
complex term
complex
alone,
conjugate. Okay, okay,
yes, complex. If I have j term, it will be minus j. I will be changing the sign. But since there is no j term here, it will be the same.
okay, ma'am.
Okay, do it. I don't know why I am not able to connect to this board. You can do it. Proceed with this. Minus 12 and 0 will be the first 2-point DFT samples, and 4 and 4 will be the second 2-point DFT's sample. The connection is also good, but completed finding 2-point DFT. What is the answer for 2-point?
minus 12, minus 12, 7 and 1.
Minus 12, minus 12, 7 and 1. Check that 7 and 1,
8 and 0.
8 and 0. Because both has 4, no? Both the samples, both the inputs are 4. So 4,
Okay,
1
ma'am.
node is 4 plus 4, 8, and 4 minus 4, 0. 8 and 0. Go ahead with the 4-point DFT's output. It is minus 12, 0, 4, and 4. Outputs are 12, minus 12, minus 12, 8, 0. Okay. Go with the finding 4-point DFT next. 4-point DFT.
Minus 4,
You have completed. Okay. Minus 4,
minus 12, minus j,
minus 4, minus 12, minus j,
minus j, minus 20,
minus 20,
minus 12 plus j.
minus 12 plus j. Is this what others also getting?
Yes, ma'am.
Okay. This is 1 and this is minus j. Okay. Go to the third step. Third step is what? You have to find conjugate of the result. Finding the, you just check it again, ma.
Ma'am, no, minus
Minus 12
j term
only,
will
ma'am.
not come, ma'am.
Yes,
0
Arjun.
Minus
is
12 only.
See, whenever you find, this is a clue also, whenever you find IDFT, definitely you will not get any J term at the output. Definitely for IDFT, you will not get any J term at the last stage of computation what you're performing. Okay. So it is 4 minus 12 and then minus 20 minus 12. Is it correct? Is this correct?
Yes, ma'am.
Okay. Take and write the answer. This is output of DFT of y conjugate of k. It is minus 4, comma, minus 12, comma, minus 20, comma, minus 12. Output will be in normal order. So I take it as such. Then for this, again, you have to take conjugate. So in the next step, you are supposed to find y conjugate of k. This is for this resultant sequence, you have to take conjugate. So if I take conjugate of this, what I will get? Sashi Kumar, can you say
Same.
what is
Same.
same? Very good. Same. Minus 12, minus 20, minus 12. Divide the entire sequence by 1. Sorry, n. So what is y of n? If I want to get y of n, it is 1 by n into this value. N value here is what? 4. So 1 by 4 into this value. Each sample must be divided by 4 to get y of n. Now tell me what is the final answer y of n?